Imagine this: a massive star, millions of times bigger than our Sun, begins to die. Scientists all over the world prepare their telescopes, waiting for the big show, a spectacular supernova explosion that should light up the galaxy. But then, nothing. The star just disappears. No blinding explosion, no glowing debris. It's simply gone, as if someone hit a cosmic off switch. Astronomers have seen this happen before. A few massive stars, expected to explode into brilliant supernovas, have instead faded quietly into darkness. And that's deeply unsettling, because if stars can die without warning, then maybe our understanding of how the universe works isn't as solid as we thought. Normally, when a massive star reaches the end of its life, things get wild. Its core collapses under its own gravity, triggering a gigantic explosion, a supernova. For a few short weeks, that dying star shines brighter than an entire galaxy. It blasts heavy elements like iron, gold, and oxygen across space. The same stuff that later becomes planets, asteroids, and even us. Supernovas are how the universe recycles itself. Old stars die so new worlds can be born. So when a huge star simply vanishes without that final explosion, scientists start asking some big questions. Where did it go? Did it collapse directly into a black hole, skipping the supernova entirely? Or is there something happening out there that we don't yet understand? Back in 2019, astronomers noticed something strange. A massive star, about 25 times heavier than our Sun, was being closely watched. It was in a nearby galaxy, roughly 75 million light-years away, and it looked ready to explode any day. For years, it showed all the warning signs: unstable brightness, massive energy bursts, and chaotic gas clouds. Telescopes around the world were practically holding their breath, waiting for the show. But then, silence. When astronomers looked again, the star was gone. No explosion, no fading light. Just nothing. At first, they thought it might be hidden behind a cloud of dust, maybe dimmed for a while. But even with the Hubble Space Telescope and infrared scans, there was still no trace. It was as if the star had just blinked out of existence. That's when scientists started to consider the unthinkable. Maybe the star didn't explode at all. Maybe it just collapsed straight into a black hole, quietly, without the drama of a supernova. Normally, when a massive star dies, it goes out in spectacular fashion, a blinding explosion that lights up entire galaxies. But sometimes, nature breaks its own rules. In rare cases, a star doesn't explode at all. Instead, it simply collapses inward, quietly, invisibly, until it becomes a black hole. Astronomers call this a failed supernova or silent supernova. Here's what they think happens. When a giant star runs out of fuel, the nuclear reactions inside can no longer push against gravity. Normally, this balance breaks violently, causing a huge blast. That's the supernova. But if the star is too massive, gravity wins completely. The entire core collapses so fast that there's no energy left to blow anything outward. The light, the shockwave, even the star's final scream gets swallowed by its own gravity. And just like that, a black hole is born. This isn't just theory anymore. In 2015, the Hubble and Spitzer telescopes observed a fading infrared glow right where one of these missing stars used to be. That faint heat signature was all that remained, the dying breath of a collapsing giant. It's eerie to think about, isn't it? A star, shining for millions of years, suddenly vanishes, not with a bang, but with silence. The universe doesn't always end things dramatically. Sometimes it just turns off the light. Spotting a supernova is easy. It's loud, bright, and impossible to miss. The cosmic equivalent of fireworks. But how do you find a star that doesn't explode? How do you catch something that disappears in complete silence? That's the challenge astronomers face. Across the world, telescopes like Hubble, Keck, and the Very Large Telescope keep photographing the same patches of sky, over and over, year after year. By comparing old images with new ones, scientists can see if a star that once burned bright has suddenly vanished. And that's exactly how the case of N6946BH1 was discovered. A massive red supergiant, about 25 times the mass of our Sun, simply faded away. No supernova flash, no debris, no afterglow, just gone. For years, researchers rechecked every instrument, every frame, but the star had truly vanished. The only thing left was a faint fading heat signature in infrared, the ghost of a dying giant. It's like cosmic detective work. Every missing star becomes a mystery to solve. Maybe it's hidden behind a dust cloud, or maybe it collapsed straight into a black hole, too fast for light to escape. Why does this matter? Because if these silent collapses are common, the universe might be filled with far more black holes than we ever imagined. Each invisible death adds to the unseen population, shaping galaxies, bending light, and warping space-time itself. And now, thanks to observatories like LIGO and VIRGO, we can even hear them. When a massive star collapses, or when two black holes merge, they send ripples through space-time, gravitational waves. These are the faint echoes of invisible deaths, reaching us from millions of light years away. So even when a star dies in silence, the universe still whispers its story. In space, death isn't the end. It's the beginning of something new. When a massive star explodes as a supernova, it forges the elements that make life possible. Iron in our blood, calcium in our bones, oxygen in our lungs. Every heartbeat on Earth is powered by the ashes of a dead star. But when a star collapses quietly, like the mysterious ones we've been following, the story changes. There's no explosion, no brilliant finale, just gravity pulling inward endlessly until even light can't escape. That's how a black hole is born, a place where time itself bends and matter becomes pure energy. Yet even these dark creations aren't entirely silent. When black holes merge, they send out ripples through space-time, gravitational waves, cosmic messages that travel across the universe. And we've actually heard them. You can watch that discovery in our video about the collision of two black holes, where we explore what happens when darkness meets darkness, and the universe trembles. Every silent collapse, every vanishing star, adds another chapter to this endless cycle of death and creation. The stars may die, but through them, the universe keeps evolving, shaping galaxies, forming planets, and giving rise to life itself. Because in the grand design of the cosmos, even darkness has a purpose. Astronomers have watched some of the universe's brightest stars simply disappear. No explosion, no debris, no trace. So what's happening? One leading theory suggests that some massive stars collapse directly into black holes, skipping the supernova stage entirely. It's as if gravity wins the battle so quickly that the star has no time to fight back. The outer layers fall inward, swallowed whole by their own immense weight, vanishing without a final flash. Another possibility is that the explosion still happens, but it's hidden. If the energy isn't strong enough to blast through the star's dense outer layers, the light may never reach us. From our view on Earth, it looks like the star just faded away, even though deep inside, chaos erupted. Some scientists also think that these failed supernovas might produce faint neutrino bursts, invisible messengers that carry clues about what really happened in those final moments. Telescopes and detectors around the world are now watching, waiting, listening, hoping to catch one of these ghostly signals. Every missing star adds a new layer to the mystery. Are we witnessing a new kind of cosmic death? Or is there something happening beyond our current understanding of physics? Something the universe isn't ready to reveal just yet? The mystery of disappearing stars is far from over. In fact, it's just beginning. New telescopes like the James Webb Space Telescope and the Vera C. Rubin Observatory are giving scientists' eyes sharper than ever before. They can scan the same regions of space over and over, capturing the exact moment a star dims, collapses, or vanishes completely. If these failed supernovas are real, we're on the verge of seeing them in action, not just as theories, but as cosmic events unfolding before our eyes. Imagine watching a star's light fade into darkness, knowing that in that moment, a black hole might be born. Researchers also hope to detect the faint neutrinos and gravitational waves released in these hidden collapses. These signals could confirm what's really happening in the hearts of dying stars, proof that even in silence, the universe is still speaking to us. The truth may rewrite everything we know about how stars live and die, because sometimes the loudest explosions in the universe are the ones we never see. So keep watching the sky. The next mystery might already be unfolding above us. If a massive star collapses quietly, skipping the supernova, what happens next? Most likely, it becomes a black hole. And when two of those black holes drift close enough, they spiral together and merge, releasing one of the most powerful events in the universe: gravitational waves. So, these vanishing stars might actually be the birthplaces of black holes, the seeds of those epic collisions we detect billions of light years away. Remember the video where we talked about the merging of two black holes? You can watch that one next to see what might happen after these silent deaths of stars. It's a perfect cosmic loop. Stars die, black holes are born, and the ripples they create continue to echo across time and space. The more we learn, the more we realize the universe isn't just expanding, it's storytelling on a scale beyond imagination.